The panorama here shows Mount Sharp in the early morning illumination on Mars. Mount Sharp is an enormous mound of eroded sedimentary layers sitting on the central peak of Gale crater. It rises 18,000 feet above the northern crater floor and 15,000 feet above the southern crater floor, higher than the southern crater rim. The sediments here may have been laid down over an interval of 2 billion years and may have once completely filled the crater. Some of the lower sediment layers may have originally been deposited on a lake bed, while observations of possibly cross-bedded strata in the upper mound suggest aeolian processes. However, this issue is debated and the origin of the lower layers remains unclear. Early in Martian history, liquid water carved the surface, forming channel systems that look remarkably similar to river valleys and drainage networks on Earth. Exactly how these channels formed by rainfall, snowmelt, or seepage from underground springs is often debated. The answer has important ramifications about the early Martian climate. Clues about the source of the water may indicate the shape, layout, and scale of the various tributaries in a channel system. The image here shows an example of just such a water-carved channel. The channel pattern, called dendritic because of its tree-like branching, begins at the top of the image and runs down over the rim of an ancient impact basin across the basin floor. The soil surface overlying these channels, and indeed the entire landscape, has been changed and reworked over the intervening millions of years by the combined actions of wind and ice. Over time, the original channels become muted or even erased. Nevertheless, some characteristics of the smallest tributary channels are still visible at scales seen by high rise. This image of a promontory at Victoria crater was taken during mid-afternoon on Mars. The upper portion of the crater wall contains a jumble of material tossed outward by the impact that excavated the crater. This vertical cross-section through the blanket of ejected material surrounding the crater was exposed by erosion that expanded the crater outward from its original diameter, according to scientists' interpretation of the observations. Below the jumbled material in the upper part of the wall are layers that survived relatively intact from before the crater causing impact. Perseverance Mars rover used its navigation cameras to capture these drifting clouds just before sunrise on Mars. Scientists on both the Perseverance mission and Curiosity rover mission are studying the formation process of Martian clouds. This panorama, featuring several of the scarps or long steep slopes of the Zero Crater's river delta, was taken by NASA's Perseverance rover. The delta formed billions of years ago from sediment that an ancient river carried to the mouth of the lake that once existed in the crater. The image was taken from a distance of about 1.2 miles. Curiosity rover snapped several views of this smooth, shiny rock in company with other smaller rocks that sport a similar sheen. The large rock looks a lot like a wayward pancake, but these close-up images often make small pebbles seem bigger than they really are. The rock may be a ventifact that's been polished by wind and sand, as Mars has plentiful supplies of both. This panorama of the downwind face of Namib Dune on Mars covers 360 degrees, including a portion of Mount Sharp on the horizon. The site is part of the dark sand Bagnol Dunes field along the northwestern flank of Mount Sharp. Images taken from orbit indicate that dunes in Bagnol Field move as much as about 3 feet per Earth year. This downwind face of the dune rises at an inclination of about 28 degrees to a height of about 16 feet above the base. This close-up view of a two-tone mineral vein at a site on lower Mount Sharp is roughly 1 inch wide. The image was taken at night and the vein includes both light-toned and dark-toned materials. The wider material appears to have ripped up and incorporated portions of both the dark vein material and a third material. Curiosity rover's examination of material in these veins may provide clues about multiple episodes of fluids moving through fractured rock at this site. The fluid movement through fractures occurred later than wet environmental conditions in which the host rock formed before it hardened and cracked. The stunning panorama here was taken by Curiosity rover looking towards the northern rim of Gale crater. Because it was peak of the dusty season on Mars at the time, it is hard to see the crater rim through all of the dust in the atmosphere. Curiosity Mars rover took this image using its mast camera, which shows a boulder-sized rock made up of many complex layers. This view is from the top of the Cape Tribulation segment of the rim of Endeavour crater. Endeavour spans about 14 miles in diameter, with its interior and rim laid out in this panorama centered toward east-northeast. Mars rover tracks imprinted during the rover's approach to the site appear on the left, and the far horizon in the right half of the scene includes portion of the rim of Yazoo crater farther south. NASA's Perseverance Mars rover is visible at the top right of center in this image, which was taken by the Ingenuity Mars helicopter during one of its flights. The two types of dunes seen here each show the wind direction in different ways. The Barkans have a steep slope and crescent-shaped horns that point downwind, while the linear dunes are stretched out along the primary wind direction. Linear dunes, however, typically indicate a wind regime with at least two different prevailing winds which stretch out the sand along their average direction. In several places in this image, you can find Barkan dunes turning into linear dunes as they are stretched out, but they both seem to indicate the same wind direction. This stunning panorama shows the Columbia Hills where the Mars rover was busy studying rocks that show evidence of past alteration by water. The dark patch of soil to the right is the spot where the rover stopped for engineering work on its right front wheel. The rover's tracks can be followed from there all the way back to a crater and the original landing site more than 1.86 miles away.